Okay, shall we start? So hope you have checked. I have posted all the videos till now, whichever is there for the internals. So even this is also there. Topic wise, I have segregated the links and I have given it in the WhatsApp. Hope you have checked it. Yes. Have you seen it? Yes or no? Okay. Are you able to hear me, by the way?
Yes, sir.
Okay. Even I am just posting it in the Google Classroom also. You can even find it there. Okay. Good. Now, shall we start the problem?
Yes, sir.
Good. In this particular problem, it says it is an open cycle constant pressure gas turbine. It has been used there. Air enters the compressor at 1.02 bar and 27 degrees Celsius. So let me draw. Okay. Let me draw the first. Okay. First PV diagram.
ಚೂರು ಮೇಲೆ ಸ್ಕ್ರಾಲ್ ಮಾಡಿರುತ್ತೆ ಕ್ವಶನ್.
ಓಕೆ, ನಾನು ನಿಮಗೆ ಒಂದು 5 minutes ಮುಂಚೆನೆ ಕೊಟ್ಟಿದ್ನಲ್ಲ ಕಾಪಿ ಮಾಡಲಿಕ್ಕೆ. Okay, please do take the screenshot. Okay, already late ಆಗಿದೆ.
ಆಯ್ತು ಸರ್, ಆಯ್ತು.
Done. So this is first immediately draw the Brayton cycle there. Okay, so mark this particular point as state 1, state 2, state 3 and 4. Now 1 to 2 is adiabatic compression, 2 to 3 is isobaric heat addition, 3 to 4 is expansion, and 4 to 1 is heat rejection, isobarically again. So now given draw the TS diagram. TS diagram. So 1 to 2 is adiabatic compression. Same thing. Adiabatic is nothing but isentropic. No? Next is heat addition isobarically. So whenever it is a curve in the PV diagram, it will be a straight line in a TS diagram. If it is a straight line in a PV diagram, then it would be a curve in a TS diagram. Suppose if in case 2 to 3 is a straight line, here it is a curve. Sorry, so 2 to 3 is a straight line in case of a PV diagram. Now here it is a curve in a TS diagram. So 3 to 4 is a curve, here is a straight line again. So there how you can match it. Now this is the thing. What else is given in this problem? Air enters the compressor at 1.02 bar and 27 degrees Celsius. So what are these parameters given? What are these parameters given?
T1.
So it is P1 is equal to 1.02 bar. Next is T1 is equal to how much? 27 in the sense, again same thing. It is 300 Kelvin. Very good. The pressure of the air after compression is 4.08 bar. So what is this parameter now? pressure of the air after compression. So this is your compression process. So this was initial to the compression. Now he is specifying pressure after compression. So which is this? What is that parameter given?
P2.
So it is the value of P2. How much is the value?
4.08.
4.08 bar. Very good. This is done. The isentropic efficiencies of compressor and turbine are 80 and 85% respectively. So efficiency of compressor is 80% and efficiency of turbine is 85%. Correct? So if efficiencies are given, what should I do in my PV diagram? What should I do in my PV diagram? So I have to draw a deviated path to meet at another point 2 dash. Similarly, since the turbine efficiency is also given, it will deviate like this path, which is the actual one, and it is 4 dash there. Same thing in the TS diagram. I am going to represent 2 dash, and now it is 4 dash. Okay, so those changes I have made in my PV diagram. That's great. Next, the air to fuel ratio is 80. Is this problem done? I remember this particular value, 80:1. Okay, anyhow, we'll see. So mass of air divided by mass of fuel. Not only mass, it is mass flow rate of air divided by mass flow rate of fuel is 80:1 in the sense it is 80. Okay. The power output and thermal efficiency of the cycle, I think they need to be found out. So to find power output and thermal efficiency. So these two things we need to find out. Okay. Now, if the flow rate of the air is 2.5 kgs per second, so he has given even the value of mass flow rate of air, which is 2.5 kg per second. So 2.5 kg per second. Just a minute. You try to solve this problem. I will come back. Okay. So power output and thermal efficiency we need to find. What else is given? CP value is given, I guess. Okay, CP value of fuel also is given. Okay, CP value was 1 kilojoules per kg Kelvin. So CP value is what? CP value is 1 kilojoules per kg Kelvin. Next, gamma is 1.4. So gamma is 1.4, and these both are same for air plus gases. He has neatly specified that. CV value of fuel is being given. CV value is how much? 41720. 41720 kilojoules per kg. Okay, so this is the problem now. So how many of you think you can solve this particular problem, or confident enough to solve this particular problem? Similar type was solved in the previous problem. One of the problem was very much similar to this. How many of you have that confidence to solve this problem? You can raise your hands. Let us see. Azim. Okay, it's very simple. So first, what they have asked is, they have asked us to calculate the power output. Okay, so what do you mean by power output? Power output is nothing but the W net. So what do you mean by W net again? It is the compressor work plus the turbine work. Now, how will you calculate the compressor work? Anyone?
MCP.
Half M.
MCP into
Okay, MCP into
T1 minus T2 dash.
T1 minus T2 dash. Very good. Since the efficiency is given, you are considering dash. Now, M ಇಲ್ಲಿ ಸ್ವಲ್ಪ ನೀನು ಇನ್ನು ಜಾಸ್ತಿ ಅರ್ಥ ಕೊಡಬೇಕು. ಬರೇ M ಅಂತಂದ್ರೆ ಏನು? Mass of air, mass of fuel. What enters in case of compressor? Only air enters, isn't it? Mass of air, only mass of air enters. Now, this is the expression. Now, work done of a turbine. Here also it is MCP delta T, but what enters in case of a turbine? Both mass of air and mass of fuel, isn't it? So, mass of air plus mass of fuel, okay, into Cp into, it is T3 minus T4 dash. Okay, so call all this equation as just one. Try to solve one by one. Let us see. Okay, I think from now we can carry on. Try to solve it. So first we shall go with compressor work. Are you able to see the screen?
Yes, sir.
Okay. So first, I have to go with the compressor work. Okay. So for this compressor work, in order to calculate that, I have the mass flow rate of air which is given. Cp value is being given. T1 value I know, but I don't know T2 dash. Okay. So in order to calculate T2 dash, I require the value of T2. So first let us calculate T2. Okay. So how do I calculate T2? How do I calculate T2?
PVT conversion.
So same thing again. So PVT conversion equation, for which process I should apply? For the process 1 to 2, adiabatic compression. Okay. For adiabatic compression, I have to apply. Very good. So if I apply it, what it would be? It would be P1 by P2, that is equal to V2 by V1 whole to the power of gamma, that is equal to T1 by T2 whole to the power of gamma divided by gamma minus 1. So P2 by P1 is beta, P1 by P2 is 1 divided by beta. Okay. Now I would take this. T1 is 300 Kelvin. 32 is T2. I have to, which is, I must calculate whole to the power of gamma value 1.4. So it is 1.4 divided by 1.4 minus 1. Beta value is how much? I guess I need to calculate the value of beta. Okay, so I will do it here. So beta is nothing but it is either P2 by P1 or it is P3 by P4. So how much it is? 4.08 divided by 1.02. 4.08 divided by 1.02. What is the value?
4.
Beta is equal to how much? How much?
4, sir.
4.1616.
4.1616.
1616.
Okay. Just a minute. So same thing you can substitute here. It is 1 divided by 4.1616. So from this, what is the value of T2 in Kelvin?
Sir, it's 4, sir.
Huh?
Beta value 4, sir.
Exact 4, huh?
Out, sir.
Okay. Oh.
445.7.
445.79 Kelvin. Okay. Now, as soon as you calculate T2, now if you calculate, for that you require efficiency of the compressor. Efficiency of the compressor in hedutte. It is actual work divided by the isentropic work.
Isentropic work by actual work, sir.
Yes,
For
you are right here. You are excellent. It is isentropic work. Isentropic work divided by actual work. Now, what is isentropic work? It is mass flow rate of air into Cp into isentropic now. Isentropic in the sense there is no dash. T1 minus of T2 divided by same thing, mass flow rate of air into Cp. Now, for an actual thing, there would be a dash. So it is T1 minus of T2 dash. So these two will go away. The remaining are just it is T1 minus of T2 divided by T1 minus of T2 dash. Now, efficiency of the compressor is how much is the value? 80%, so you have to take it as 0.8. 0.8 is equals to 300, which is the value of T1, minus T2 is 445.79 divided by T1 is 300 minus T2 dash is the value that you need to find out. So from this, what is the value of T2 dash in case of a Kelvin?
$482.23.
482.23. Just check the value. If it is the same value, then no issue. If it is a different value, please let me know. What is the mass flow rate of air given? Mass flow rate of air is 2.5 kgs per second. Cross Cp value is 1. Cross T1 value is 300. Minus T2 dash value is 482.23. Now just check for the units. M is in what? M is in kg per second. Cross Cp value is in kilojoules per kg Kelvin. Cross T1 and T2 values are in Kelvin. So kg, kg, Kelvin, Kelvin goes away. So whatever is remaining is in kilojoules per second. So joules per second is watt, so it would be in kilowatts. So whatever answer you get here, WC, that would be in kilowatts. It's a value.
Minus 455.57.
Minus
455.57.
455.57 kilowatts. Okay, keep that value aside. Next, you go for the calculation of WT. So WT, if you want to find out it, so you don't have the value of mass flow rate of fuel, isn't it? Mass flow rate of fuel is not there. For that, you have m dot A divided by mf dot is equal to 80, which is a given value. Okay. From this, 2.5 is the mass flow rate of air. M dot of F is equals to 80. So from this, what is mass flow rate of fuel?
0.03125.
0.03125. So once you have calculated that, next you require the value of T4 dash. So for T4 dash, you require a value of T4. So now T4 we have to calculate. So how we are going to calculate T4? Again, you are using PVT conversion equation for process what? 3 to 4, which is adiabatic So for an adiabatic process, if you apply a PVT conversion equation, it is P3 by P4. That is equal to V4 by P3 whole to the power of gamma. That is equals to T3 by T4 whole to the power of gamma divided by gamma minus 1. P3 by P4.
Four.
P3 by P4 is directly beta there. Okay. So next is that is equal to, now from this, do I have the value of T3? Do I have the value of T3?
Yes. P3 is equal to P2.
What is T3? T3. Temperature at third state after heat addition. Do I have it? Do I have the value of T3? So what you do is,
So
again,
screen recording stop.
recording stop. Sir, ಇದು
ರೆಕಾರ್ಡಿಂಗ್
PPT
ಅಲ್ಲ
ಇಲ್ಲ.
ಸ್ಕ್ರೀನ್ ಇದು ಸ್ಕ್ರೀನ್ ಕಾಣಿಸ್ತಿಲ್ಲ.
ಓಕೆ ಗೊತ್ತಾಯ್ತು. ಈಗ ಕಾಣ್ತಾ ಉಂಟಾ?
ಹಾ ಸರ್.
Now you need to find the value of T3, correct? So T3 ಹೇಗೆ find out ಮಾಡೋದು? There is a way. Now you require T3 for the further calculations. No, how to find out T3? So Kev 2 to 3 is nothing but Kev. Yes, am I right? Whatever the heat is supplied in Kev 2 to 3. Am I right or wrong? Yes or no, man? Heat addition takes place in
Yes,
process
sir.
2 to 3 or not? So, how will you calculate the value of Q of 2 to 3? Again, it is MCP delta T. No doubt about it. Okay. Again, it is MCP delta T. But what is M? And what is delta T? CP remains the same thing. No issue there. But what is M and delta T? I told you for heat, it is final minus initial. And the fuel gets entered from the point 2. The fuel gets entered from point 2. So both air and fuel would burn from the heat, combustion chamber. Again, it will enter into the turbine. Now, what is M and what is delta T now? How to frame this? Q2 to 3. How do I frame it?
MA plus MF.
Excellent. It is MA plus MF. Now it gave the complete meaning. Cross CP cross heat is in final minus initial. So what should I take it as?
T3 minus T2 dash.
Hey, super kana. T3 minus T2 dash. You should not take T2 since efficiency is given. You have to take T2 dash there. Very good. So this is the value of Q2 to 3. Very good. Okay, now I will keep it here. So this is all as Q2 to 3. So that is equal to what is heat supplied? How will you
Sir, can you
calculate heat
go up,
supplied?
sir?
Huh?
Can you go up?
Up, okay. Why?
Yeah, T3 value. Can you go up?
Huh.
Up.
Okay.
Yeah. Okay. Up, please. Okay, thank you, sir.
Okay, fine. Come back here. Now, how will you calculate the heat supplied by the fuel? This you know since from IC engine chapter. How do you calculate the heat supplied by the fuel?
MF into CV.
Excellent. So it is MF dot into CV, right? From this, substitute all the known parameters. MA dot is in 2.5 kgs per second. MF dot is 0.0 something 0.03125. 3125. Next, CP value is 1 cross T3 value that I need to find now. Minus T2 dash value is how much? 482.23. 482.23. That is equal to MF dot is 0.03125 cross CV value is how much? Anyone could give me the CV value? Again, I have to scroll to the first. So 41720 kilojoules per kg. 41720. Now you have substituted the things. Please check for the units. Both the sides of the unit should be same. So MA and MF dot would be in kgs per second. Cross CP value is in kilojoules per kg Kelvin. Cross temperature value is in Kelvin. So Kelvin get cancels. Kg get cancels. It is kilojoules per second. So it is kilowatt on the LHS. That would be equal to MF dot would be in kgs per second and CV value would be in kilojoules per kg. Now kg get cancels, so it is kilojoules per second once again and it is kilowatt. So both the units are matching, then your value, whatever you get, that should be right. What is the value of T3 from this?
997.29.
997.29 Kelvin. Okay. Now, once the value of T3 is obtained, continue from here. Okay. Continue from here. Wait, I will take it as T3. T3 for the calculation of T3. I have done this. So if you want, you can write the sentence here. I will just write it. Wait a minute. So pick this particular thing. Cut. And I will paste it here. Okay. Now, so you just write a sentence here. Heat gained. Heat input, you can say. Heat input to the system is equal to heat supplied by fuel. Okay. So this all you have done to calculate the value of T3. So T3, in order to calculate T4, you know, T3 was unknown. Not was, it is unknown. So therefore, now going to calculate T3. Content outside. Now, come back to the previous step. Yeah, found out the value of T3, that is 997.29 divided by, you have to find out the value of T4, whole to the power of 1.4 divided by 1.4 minus 1. Beta value is 4. Am I right? Is the value of beta 4?
Yes, sir.
Yes, sir.
So either in the, give me the value of T4.
671.12.
671.12. Just check the value of remaining. If it is a different thing, let me know. So once the value of T4 is obtained, use the efficiency of the turbine. So here it is actual work divided by isentropic work. Just a minute. Go on with the calculations. Okay. So actual work ಏನಪ್ಪ? Same thing again, ma dot ಇಲ್ಲಿ ಎರಡು ಬರ್ತವೆ. Mass of air plus mass of fuel into Cp into T3 minus of T4. Actual and takshana, should I put a dash there?
Yes.
Should I? So divided by, same again, Ma plus Mf into Cp into T3 minus T4. So this is isentropic without dash. Now we will clean up the way. Next, whatever is remaining is this is 0.85 answer, correct? That is equal to T3 minus of T4 dash divided by T3 minus of T4. So that is equal to T3 value is 997.29 minus of T4 dash, you have to find it out, divided by 997.29 minus of T4 is 671.12. So this is 0.85. From this, what is the value of T4 dash?
Seven 720.04 Kelvin.
720 point
04.
0.04 Kelvin. Very good. Now, for all this, what you have done is pick this particular expression. Okay. In this particular expression, substitute all the things. 2.5 plus 0.03125 cross 1 into T3 is 99729 minus 720.04. Now, what is the turbine work output? So already you have massed the units, that would be in kilowatts. What is the value? Lastly, you calculate your power output. That is W net. That is WT plus WC. What is the value of WT? WC is minus 455.57. It is minus 455.57. WT, what is the value?
Seven zero 1.78.
701.78. Okay, just substitute it here. 701.78. Give me the value of power output.
$246.21.
Okay, now this is the first part. Second part, which was asked, is the thermal efficiency. Right. So efficiency of Brayton cycle is given by W net, output by input, divided by heat supply. So W net, you already have the value as 246.21 kilowatts, divided by QS is nothing but EMF dot into CV. So it is 246.61. EMF dot is 0.03125 cross CV value 41270. Just check the value. I have not checked. 720. 270, 720. So it's 720. So if you multiply the whole thing by 100, you will get it in percentage. So the thermal efficiency of Brayton cycle is how much?
$18.91.
18.91. Okay. So this is how you calculate the efficiencies in the power output of the Brayton cycle. Now we shall end the class here. Before we end the class, please take this particular problem, take a screenshot, that's enough. I'll have to take the screenshot. Okay. Done. taken?
Yes, sir.
All of you please to take the screenshot. After that, one more problem. This. Now you take a screenshot. One more screenshot, everyone. Okay. So tomorrow you don't have a class. Okay. Within Monday, all of you have to solve these two problems and submit in the Google Classroom within Monday. These two problems, all of you have to solve it and you have to submit in the Google
Assignment, sir.
Classroom.
Assignment.
Assignment alla. Assignment ನಿಮಗೆ ಕೊಟ್ಟಿಲ್ಲಲ್ಲ? I have not given you
ಇಲ್ಲ.
assignment, isn't it?
Yes, sir.
So you can take this particular thing as an assignment and submit within Monday morning 9 o'clock. Okay.
Okay.
Two problems. Okay. Okay, then you can mark your attendance in the Google Sheet. Have a great Sunday. Enjoy your weekend. It hardly takes half an hour, man. Okay. Write it and submit. It will be accounted for assignment number 1. Okay. Take care of yourself. Be at home. Be safe. We'll meet up in the next Monday.
Thank you, sir.
Okay.
Thank you, sir.
ಸರ್ ಅದು ಹಾಗೇನೆ ಉಂಟು.
ಒಂದು ನಿಮಿಷ ಚೇಂಜ್ ಮಾಡ್ತಾನೆ. Just a minute.
Thank you.